Thanks for joining our talk, how Mercedes-Benz is securing 900 Kubernetes clusters without pod security policies. My name is Tobias Giese. I'm a software engineer working for Mercedes-Benz Tech Innovation since 2017. I'm a certified Kubernetes security specialist, and I'm involved into Kubernetes since, I think, 1.7 or something. I'm a former maintainer of the cluster API provider for OpenStack, and I really love hearing and collecting records, and I also love to optimize my home office desk setup.
Yeah, my name is Tjark Rasche. I'm also working as a software engineer at Mercedes-Benz Tech Innovation. I've been working with Kubernetes since about version 1.13, I'm not really sure. I'm very active in the local Kubernetes community. For example, I'm the initiator of the Kubernetes meetup in our beautiful Swabian hometown of Ulm. And got a few Ulmers here. And also, I love making and teaching music, especially playing the drums. So we work for a company called Mercedes-Benz Tech Innovation, which is a 100% subsidiary and strategic partner for Mercedes-Benz. Our company has been developing software for Mercedes-Benz since 25 years. Yeah, we have around 1,400 employees who work in different business streams. They're called one customer, car sales, car after sales. And of course, from our point of view, the most important stream, technologies and security, where few people provide cybersecurity services for all of Mercedes-Benz. And of course, we, the platform engineering guys, provide cloud services and infrastructure for all of Mercedes-Benz. So our team runs the main managed Kubernetes platform for all of Mercedes-Benz. We run round about 1,000 Kubernetes cluster. We cannot say the exact number at the moment because it's a full self-service platform. So every engineering team at Mercedes-Benz could provision or deprovision a cluster at any time, but it's around 1,000. They run in 8 different zones, so data centers which are located in 2 geographic regions, one in Germany, one in the US. And they run on-premises and in the public cloud. We provide both. So before we can go into the deep details and how we work on our security setup, we first have to explain what managed Kubernetes actually means at Mercedes-Benz. So our engineering teams don't have to think about Kubernetes operations at all. That means they don't have any access to the nodes, so no SSHing into the nodes, but also they don't have to think about stuff like what operating system is the node running, what's the network infrastructure looking like, stuff like that. They don't have to think about that at all. Second, maybe even more important aspect, is that we have very strict security lockdowns on all of our clusters so our customers have to think less about Kubernetes operations. For example, no engineering team can start root containers on our platform. They're not allowed to mount host path volumes. And also, which is a bit more tricky to implement, we totally block system namespaces. So for example, no engineering team but us can access any resources or change or edit them within kube system, for example. Yeah, and how we actually did or implemented that before our upgrade to validating admission policies is Toby's time now.
Yeah, thanks. Okay, so let's talk a bit about the status quo of Kubernetes 1.24, which was 1 year ago in our case. So we used PSPs, or pod security policies, to enforce the pod security in our Kubernetes clusters. Also, we're using Open Policy Agent. This is running as a static pod manifest because we have to run this completely independent because we add this pod or this container as a kube API server parameter because we're using the authorization webhook. Also, we are handling validating webhooks and, like I said, the authorization webhook. Let's take a deeper look into the authorization webhook, or more like the kube flow of an API server request. So here you can see the complete workflow. A user creates a YAML or a GET request. And first, the authentication and authorization webhook will come in place. So here we can handle, for example, the deny of a impersonate, or we also deny the deletion of nodes, and so on. Next step is the mutating admission controller. Here we can default things or update things. And next step is the object scheme validation. This must be after the mutation because we want to check if or Kubernetes checks if the scheme is valid. And last but not least, the validating admission controllers webhook. So here we can validate if the manifest is valid or not, if we wanted to allow it or deny. I will talk about this later, but we are using validating admission policies, and this is the same step here. Last but not least, it will be stored in the etcd, and it's done. Okay, so let's give you a quick overview about the complete journey of our replacement of pod security policies. First, like I already said, we are using pod security policies. In the next step, we tried to use Kyverno or Gatekeeper and other policy engines, but this was not really feasible because we had performance issues. We had benchmarking, we will see this later, and we had request responses up to 11 seconds, and this is completely no-go. Last but not least, the validating admission policies started to evolve with Kubernetes 1.26, and this is where we are now. Okay, so, Tjark. Sorry. You maybe noticed there's one thing missing on the slides, and it's the pod security standards. So why don't we notice this here?
Yeah, for those of you exactly following the development of policy enforcement and pod security in Kubernetes, you may ask yourself, wait, pod security policies were removed after 1.24, but they added pod security admission and the feature of pod security standards. And to be totally clear, pod security standards are a really great and well thought out feature. It's basically just you can categorize a pod and map it to one of the available security standards, and then Kubernetes will automatically enforce very same default security practices on that pod. So that is pretty great because you don't have to think about that at all. People who really know their stuff, the core maintainers, will always update the pod security standards. So no matter what API changes or future changes happen in Kubernetes, this standard will always be up to date, and you don't really have to think about pod security at all. And while this opinionated matter is very good for that reason, it's also bad for us for the same reason, because it is very opinionated. And it gets in the very low details, but for example, we have, down on a capability level, things we want to allow, which pod security standards would block. A very concrete example for that is the net admin capability. If you want to know more about that, my colleagues Tobi and Mario, he's somewhere in the audience, once wrote an article why I want to allow that on Medium. And we also have a few syscuttles we want to allow and stuff like that, so we're very detailed. So let's real quick talk about what we actually would need from a custom policy solution. First of all, and I think already quite well explained, is we need a very flexible way to define policies for pods, but also it would be cool if we could define policies for other resources as well, for deployments, cron jobs, stuff like that, but that's a pure user experience issue. Another thing that's very important for us is a thing we call cluster pollution. We're a very large organization. There are several thousand engineers working with our Kubernetes clusters. So there are several thousand opinions on which tools are the best to use and stuff like that. And we want to enable customers to use the tools they want. And so if we would implement our custom policy solution with tools needing, for example, custom resources, other cluster scope resources, we would hinder the user or the consumer of our clusters, the engineering teams, from using the same tool. So we'd really like to keep out of the customer space there. And last, but not at all least, it's very important for us, but actually for everyone who wants to really run secure pods enforced, to also be able to mutate resources. That sounds a bit weird at first, but the only reason why we need that is because Kubernetes tends to have quite insecure defaults for some details in pod security. For example, most of you will probably know the flag allow privilege escalation on a pod. If that is not set, the Kubernetes core will actually default the flag on a Linux level, new privileges to false. So, but we would want that to be true, to be secure by default. Well, that's a very concrete example of stuff why we want to mutate if people don't set flags like that at all, which most users don't do, because probably most users who just want to write a deployment don't think about that stuff at all, which is good. That's why we are here, the platform team. Okay, cool. So now let's take a look at the main open source tools, the players in that field, which we could use, which we looked at. The two big players in that space are Open Policy Agent and Kyverno. And we already use Open Policy Agent as a static pod on every node, as Toby already explained. So that seemed like the pretty logical choice for us. But a very big drawback of Open Policy Agent is that it's very, very complex to implement policies with it. It comes with its own Turing-complete, full-blown programming language just for policies called Rego. And we're quite a small team. We're only 6 people running the clusters themselves. And so we would really like to introduce as little new technology or technology we're not very familiar with as possible. Also, when used in the way we already did it, Open Policy Agent is not really Kubernetes native, because if we wanted to change policies, we would have to change them on the node somewhere, and we cannot do it via the API server. You can use Open Policy Agent or the same policy agent with Gatekeeper. Then it is Kubernetes native. You can manage all policies with the API server, but in that case, it pollutes the customer cluster, as I explained earlier. Yeah, the second really big player is Kyverno. It also checks almost all the boxes. You can mutate, you can write policies, and you can write them in a very Kubernetes-y way, is what I'd say. Like everyone who is very experienced writing Kubernetes manifests will be able to write a Kyverno policy in quite a short amount of time. It is Kubernetes native. All policies can be managed via custom resources and via the API server, but it does need, obviously, custom resource definitions, so it would hinder users from using Kyverno themselves. But that whole pollution thing, it's not a hill we're willing to die on. It's just something that we really strive for. So we've settled actually on Kyverno in our first iteration. So let's talk about what was our experience like with policy enforcement in Kyverno. It was actually a pretty great user experience. We were able to really achieve a great readability and a great maintainability. It really just reads like normal Kubernetes manifests all of us know and work with daily. And we actually had all our policies, which is quite a large stack and quite complex, implemented in a few days. And we had to work a bit on our end-to-end tests because they were quite pod security policy specific, but we had them passing a few days later as well. And at that time, we thought, oh, cool, goal is reached. We're ready to go. Let's go into canary deployment. Toby, what happened then?
Yeah, thanks, Tjark. So the first day of our canary deployments were like this little fella's looking like, and not really cool. It was pretty disappointing. So for example, we have a canary cluster customer that is using a development cluster, and he is deploying a lot of controllers and operators into it, and these controllers are updating the pods every 10 seconds. So they update the annotations and labels, and because of this, and also because of a failure of us, Kyverno also enforced or mutated things during a pod update. This is not necessary because everything is not able to change. It's immutable, beside for the image. But yeah, this was a failure by us. But we had to benchmark the Kyverno controller somehow. So we have to stress test it, and we have to take care of this. So we started benchmarking. So how did we do this? We are using K6 from Kyverno Labs, and to be compatible to a real cluster, we used kind and add a max quota of 2 CPUs to this, because our smallest control plane nodes have also two CPUs, and in this case, we are some kind of equivalent. We used 100 virtual users as a parameter for K6 and also 1,000 iterations. This means that during the stress testing, we are doing 100,000 API requests to the Kube API server. To do an API request, we used a simple pod manifest, which is a valid manifest without any specifications, just an image, name, security context, and that's it. And also, we used the dry run for this. OK, so let's take a look at the benchmarks. Yeah, and this is pretty awful. So pod security policies responds during the stress load with a maximum response time of 0.4 seconds, and Kyverno is at 11 to 12 seconds. The medium response time is at 4 seconds, and the minimal response time is longer than the maximum response time for pod security policies. This is not really feasible for our fleet, because if you take green IT principles in mind, this scales nowhere. So we have to take a look at of alternatives. So we went back to the drawing board and created a battle plan. So we had 3 little teams, and each team is doing their own things. So we had one team for the open policy agent implementation. So we have it already implemented. There's an existing setup. But someone has to write the policies for it to replace the port security policies. Next, we had a team that is there to write a custom controller. So we can do this because we have enough knowledge to create controllers. We're using KubeBuilder for this, and it's pretty easy to do this. So this team is creating the custom controller. Then also another team is improving our benchmarking suite. For this talk, we used this improved benchmarking suite, but we had to implement this somehow. OK, so well, this is a really good plan, but we are running out of time because we are currently want to update from 124 to 125, but 126 is already around the corner. So we have to think about this as well, because we don't want to tail behind too far. OK, so we created a plan for this as well. So we can easily update our control plans from 124 to 125. And if this is done, we can update the control plans to 126. And regarding the Kubernetes school policy, we are then able to update all of our worker nodes to 126 in one update step. So this is pretty cool. During reading the release notes of 126, we then found, in our case, the holy grail, because validating admission policies started to evolve in Kubernetes with 126, and we can use this alpha feature easily because we have a really good end-to-end test suite, and we can test this and add this also to production. OK, cool. But what are validating admission policies? Validating admission policies allows us to add custom admission logic, and we can do this and create this to customize it to our needs as well. OK. And also, it is lightning or pretty fast, thanks to in-memory abstract syntax tree. And also, like Tjark said it before, there's no additional control and also no CRD needed because we don't want to pollute our customer clusters. OK, cool. That is really high level, but what is a validating admission policy in technique?
Yeah, so let's just build some validating admission policies, right? By the way, the image you can see, that's how my grandmother imagines my job. I'm an engineer at Mercedes, right? OK, so let's talk about validating admission policies. Very basic, what we want to do is we have an input, the admission request, we want to do some custom logic, and then we want to arrive at a policy decision. A cool feature which validating admission policies actually support, but which is optional, is we can also define a custom resource as input as well for validating admission policies, so we can inject custom configuration values. Yeah, the admission request, I guess, is pretty clear. It comes from the API server. It just contains what the user actually wants to do. Let's take a look at an example of validating admission policy to see how we can configure the custom resource as input. So this is a very, very basic validating admission policy. And if you have a detailed look, you can see the param-kite property. And it's just a custom resource reference in there. Our custom resource is called admission exception. We have lots of custom controllers running as well in all of our clusters because we have like cool cluster add-ons. It's basically my main job to develop them for our users. And sometimes these controllers want to do things which would actually be not allowed in our policies. So it's cool for us to have the ability per cluster to manage a list of admission exceptions, to our admission controllers. So in our case, the custom resource is just simply a list of service accounts and their namespace. Yeah, but if we have that configured, we also need a way to tell Kubernetes which custom resource to use as input for the validating admission policy. For that, Kubernetes also introduced a new resource called validating admission policy binding. And it's very similar to other resource binding types of Kubernetes, like you probably know cluster role binding or role binding, very similar stuff. You have a param ref, which just references the custom parameter, in our case, the admission exception custom resource, by name. And also you have the policy name, which references the regarding policy by name. OK, so we have both our inputs done. Now we need to implement the custom logic. yeah, we can take another look at our at our validated admission policy here, and see the validations field down there. In this case, we only have one expression, but you could actually add as many as you like. But for the simplicity of this talk, we only add one. And you can actually see there's a very simple expression written down there in the expression, and that's in a new language introduced by Google, which is called Common Expression Language, or short CEL. What is CEL? CEL was developed by Google explicitly to be used in critical code paths. So it is guaranteed to be evaluated in linear time. That's possible because it is mutation-free and not Turing-complete, very computer sciencey terms. It basically just means you cannot do stuff like for loops. You cannot mutate any variables, stuff like that. What it means for us is that it's very fast, and that's very good. And it's guaranteed to be very fast. Yeah, and if we take a very simple example like this one, I think probably most, if not everybody in this room can already get what that's doing, because it's just some expression. Like, it's very similar to other languages. We take the object, which references the input from the admission request itself, and check if the service account name referenced, in this case it would be a deployment, is in the list of excluded service accounts. So the params is basically referencing the custom input from the CRD. Yeah, this looks cool and very fine, but I have to warn you, if you want to write complex validation with CEL, this is a more realistic example of how policies look. Yeah, quite an unreadable mess. But we can look at a few details which are actually great examples for downsides of validating admission policies as well. So if you look at that part, you can see that we have to repeat ourselves a lot, because we want it to be like the user experience to also not only validate the pods for security reasons, but also to not allow deployments if they have forbidden pods in them, for example. So we have to write stuff like this, lists of resources we want to check, stuff like that. And another way more important, because security critical detail, you have to think a lot about the details of sub-resources in pods. There was in 125 a feature introduced called ephemeral containers. Those are containers running on your node. If you forget to enforce policies on them, you could just don't use policies at all. There's also quite new in the newer versions of Kubernetes now, sidecar containers natively supported. And if you're writing in CEL, you have to write that out all one after another. So the gist of it is, we started writing this stuff manually, but quickly realized that it's not fun at all. It's also very error prone. We realized that because we thought we're done, but our end-to-end tests were still failing. So you will need, if you want to build something like that, something to generate your code. In our case, it was just a quite simple Helm setup, because all we basically have to do is repeat the policy we want to enforce for ephemeral containers and stuff like that. But this is very highly dependent on the policies you would want to enforce. Yeah. So we've got our custom logic implemented as well in CEL with some code generation. And now we're done, it seems like it, right? We thought that before, but now we're done, right? But there is a detail missing. Like, what about Toby? Can you tell us more?
Yeah, thanks, of course. So we also have to think about the mutation. Oh, no, it's working here. We have to think about the mutation of pod resources. So the validation is working, but what is with the mutation? There's the same feature like the validating admission policies coming in Kubernetes 131, hopefully, called mutating admission policies, but this is not available currently, so we have to think about something different. So if we go back to the drawing board, we can see, okay, there was a team building the custom controller. Okay, this is pretty cool, because we can remove the validation part, but only use the mutation part. So we have to mutate the allow privilege escalation to false and run as non-root to true. That's it. Okay, cool. Now, after this in mind, we can say we have a final setup that is pretty cool. We have validation in lightning speed via validating admission policies, and we have the mutation over this tiny custom controller, which is really, really tiny, and that's it. So is it really faster than Kyverno? Yeah, I think it is. Okay, so our max response time is at 1.2 seconds, and the average response time is at 0.4 or 0.37. In comparison to Kyverno, it is really much faster. Cool. So we are done, right? Yeah, I don't think so. By the way, this is my cat, Clyde. It's a real photo. He's also a Kubernetes engineer. He committed a file once in our repository, but this is another story. Okay, so, but why does he have this skeptical stare? So we have Kubernetes, we have the validating admission policies in 126 and pod security policies in 124, but what is with 125? We don't have anything here. So let's get back a last one more time to the drawing board and take a look here. So we had there also a team implementing the open policy agent policies. So we can use this for 125 with the admission controller, and we can use the validating admission policies with the admission controller for 126. That's perfect, so we are ready to go. Okay, cool. By the way, our future plans are using validating and mutating admission controllers, policies to remove the HTTP overhead and have everything built into Kubernetes. That's very cool. Okay, then let's take a look at the final benchmark comparison. So we have here, this are our validating admission policies. We have PSP underneath, and we can see it is even faster than Gatekeeper or Open Policy Agent, and it's much more faster than Kyverno, which is really good in our case. That is really cool. So, but let's take a look back what happened since then. So we have implemented this the first 2 quarters of 2023, but Kyverno improved the performance by far. Especially thanks to our colleague Robin Afflerbach, because he has contributed the benchmarking of K6 to Kyverno, and they were able to test this with their implementations, and they saw that there was really a downside. So they improved it by far, and just to notice this, Kyverno also can generate validating admission policies now, so you can add CEL, also common expression language, to the Kyverno cluster policies, and it will create the validating admission policies for us. And also we have reporting for this. This is quite cool. So let's take a look at the Kyverno 112 benchmarking. It is really, really better now. So we have an average response time of only 1.2 seconds, and the minimum response time at 0.1, which is really great, and also only possible because our colleague has contributed everything to the Kyverno team. Cool, but last but not least, we have, I think, a few lessons learned, and Tjark will talk about it.
Yeah, what have we learned? First of all, benchmark your policies. We mean it, really, benchmark your policies. We would have saved a lot of work if we would have thought of this from the beginning. Yeah, and another very important thing that we noticed or learned doing this is that good and really tool-independent end-to-end tests are crucial if you want to iterate really quick and if you want to build fast but also fail fast. I mean, basically we had implemented the same thing 3 times, you could argue even 4 times, but it wasn't that huge of that much of a time invest we did, because we could always just build it, run the end-to-end test. If it's not red, it's wrong. But we were very confident if we had all of our policy needs filled up with the code we developed. Another very important thing, if you build your own policy solution, but this is no matter how you do it, you will have to take care of the nitty-gritty details of sub-resources on pods. And you will also have to take care that if new features will be added, you think about that. So you have to very closely monitor everything that's happening in Kubernetes development. I talked about ephemeral containers and sidecar containers before. That's the stuff. Maybe there will be new sub-resources added in the future. You would have to think about that. So yeah, in the end, you can say we paid a price for early adoption. We really did. But we really don't mind that. I mean, we're called Mercedes-Benz Tech Innovation, not Tech Trail Behind or something. Yeah, and the most important learning is that a pure Kubernetes solution is not only feasible and possible, but it's also quite maintainable. We have basically just a Helm chart rendering a few policies. I mean, I guess everyone in this room has done that before. It's no rocket science, it's just Kubernetes. And so we're actually really, really happy with our final solution, and we will even be more happier if we can replace that tiny controller still running with mutating admission policies, and then we're completely doing all of our validation and mutation within the API server with no HTTP overhead or anything at all. And that's already it. Thank you very much for listening to our talk. If you have If you have any questions, don't hesitate at all to ask them, but please use the 2 mics which are provided, so the people watching digitally can also hear that. And I have to say this, it's very important, we're hiring, and if you're interested in working with us, there's a QR code, you can scan it, and I'd love to become colleagues with, probably not all of you, but maybe.
Hi. Thanks for the talk. I'm not really familiar with the validating admission policies feature inside of Kubernetes, but as far as I understand, like you can only validate stuff that's in the spec of that resource that's being admitted, right? Is that correct?
That's correct, yeah.
So you might be familiar, but in Gatekeeper, there's a feature called External Data Provider. So it allows you to basically hand off some validation that can explore some external data that's not in the Kubernetes resource.
Yeah.
Do you have any use cases like that where you want to validate something, maybe something to do with the image itself that you need to pass that off to something else? And yeah, do you think that there's any shortcomings in terms of validating admission policies related to that kind of thing?
There are definitely shortcomings in validating admission policies regarding that, but I wouldn't really call it a shortcoming because these are running in memory within the API server, so they're very focused on critical code path performance. So stuff like that would never be possible and also will never be possible. But complex validation like that, like we do stuff like that for a lot of things, but that's nothing that would happen all the time just because someone is changing resources on your API server regularly. So you could do that with the traditional way of admission webhooks and stuff, custom controllers, how you'd like, but you probably would not want to have that for every single request reaching the API server, because if you run stuff like Argo CD, or we have teams running very custom controllers, they tend to update resources every few seconds, and then you get the problems of huge overhead. Yeah.
Thank you.
Thank you for the talk. It was really interesting. I have a question regarding Kyverno slowness. So what it's based on your setup and what load on your kind of cluster you have, and complexity of the policies, or the framework in general was slow and doesn't matter what kind of policy you use or load you generate on your cluster?
I think it's a mix of different things. So Tjark is going back to the a lot of slides. So basically, we only use a kind cluster to reproduce our problem with the high load. So this is exactly the slide I think this answers everything, because we just added a kind cluster without anything in it, but we added our complexity, our policies to it, yeah, for sure. But I also think that Kyverno is lacking of performance even with a single policy. We haven't tested this, so because we implemented everything that we have done with PSPs, so maybe this is something we can try.
I mean, our policies are quite complex, but the important thing is that these comparisons, we implemented the exact same rule set of policies. So it is comparable. It's very possible that if you have a less complex set of policies, Kyverno is totally fine with that, but we have a very, it's not rocket science, but we have quite detailed and complex policies, and the important thing is the comparability, and we implemented the exact same rule set on all of them. We guarantee that thanks to our cool end-to-end tests, yeah.
We also tested to remove some special policies from the Kyverno setup, but it doesn't improve anything there, so it's still slow. It was still slow.
Cool, thank you.
Yeah, thanks as well for the nice talk. I know the pain of getting rid of PSPs, and yes, in the end we adopted Kyverno. What I'm really curious about is how does your end-to-end test up look? Could you outline that maybe in a few sentences?
Do you want to, or
I can.
should I?
How does it look like?
So basically,
Go ahead.
So basically, we are using the Ginkgo framework to use end-to-end testing, and we are just testing the pod creation of different things like we add a root container to it, we test that the mutation is working, we test the volumes and so on. So it's just a simple pod creation, and that's it. So we are not testing, we are not end-to-end testing the deployment daemon-side validation, so because pod is totally fine.
So basically the setup is specific to the policies. Those end-to-end tests are specific for testing the policies and not like...
Basically, we have a set of rules we want to enforce. And we have a test coverage for every rule we want to enforce. But that test coverage is not dependent on some error message by some tool or something. It just checks if it gets admitted or not.
Okay, thanks.
Yep.
Hey, thank you so much for your presentation. That was amazing. I have just a quick question about policy exception. I'm very curious to know how you manage that, because I think in this case with close to 900 cluster, I'm sure you need to have exception, and sometimes that you need to have maybe some temporary exception and some permanent exception. And I'm very curious to know how you manage that here. And thanks again.
Yeah, there's two ways in which we use the admission exceptions in our case. We have controllers reconciling stuff, like we have custom add-ins for clusters. You can, for example, deploy Istio with a single CRD and Datadog, stuff like that. And these controllers, sometimes if they need to add privileges to some specific stuff, are able to manipulate these CRs who are deployed in every cluster anyway automatically. And the second use case is when we have customers where we can trust that they know what they're doing or have very specific needs. We can also edit this manually, and we have tooling that we call it snowflakes, that those are applied automatically on upgrades and stuff as well.
This can happen, but we never allow the customer to use root containers or something.
No, of course not. But we have very...
But yeah, thank you so much for your answer.
Perfect.
Okay, so on our side, we are also using Kyverno, and then I would like to ask, for example, with Kyverno, we can also do some kind of, image validation, right? So then, for example, you can restrict to certain registry, and then, even to certain version of some images. Is it still possible with this new approach?
Sure, of course. You can validate everything which is inside the spec of a pod, and you can validate if the registry starts with a certain string, and yeah, you can do this as well, of course.
And then with Kyverno, it's also possible whenever you create like a policy exception to actually say that, you want to keep it alive only for, I don't know, X amount of time, So it's...
That's not directly possible. I mean, you could probably create like a scheduled job or something for that time, but...
We don't want to say that Kyverno is bad. It just doesn't fit to our needs.
Yeah, no, sure.
Kyverno is a really good user experience.
That's basically the trade-off, right? Now that stuff like that is not possible, it also will not be possible because we're talking about very core API server features here, so they're not going to build some scheduled thing in there or something.
Hello, thanks for the talk. I was just wondering if any of the policies or maybe the Helm chart you use to render all the sub-policies for the sub-resources, is this open source somewhere or just internal?
No, we're not allowed to open source that. We asked.
But maybe we can do another round, so maybe that's feasible somehow. If you need it, maybe we can do it open source, but currently it's not possible.
Okay, thank you.
Yep. Cool. Thanks.
Thanks for coming to the talk.